Elon Musk recently revealed that Giga Bay construction has officially begun. A short announcement, but one that marks a historic shift for the future of advanced aerospace manufacturing. Even in this early stage, Giga Bay carries enormous expectations. SpaceX plans to overhaul rocket production at a pace and scale the industry has never witnessed, pushing for breakthroughs in efficiency, output, and next-generation Starship manufacturing. Just how ambitious are these goals, and why could Giga Bay redefine the entire rocket production landscape? It's fair to say that as Starship evolves with each new version, every part of Starbase must evolve with it. The future of Starship will depend not only on increased capability and power, but also on SpaceX's ability to build and launch these vehicles at a scale the aerospace world has never experienced. Achieving that vision requires a production system that is fast, powerful, and capable of supporting a launch cadence unlike anything operating today. That is the mission behind Giga Bay. From the moment construction started, this monumental facility was assigned some of the most extreme manufacturing goals ever attempted in rocketry. Musk summed up the vision with a bold phrase on X: "So many spaceships will be born in the Starbase Giga Bay." That confidence reflects the scale, ambition, and transformative potential behind the project. During a company discussion earlier this year, Musk laid out Giga Bay's long-term target. He said, "Where we're expanding integration to produce 1,000 Starships per year." Well, yeah, that hasn't been built yet, but we're building it. That is a truly enormous structure. This will be one that'll be one of the biggest structures, and by some measures, the biggest structure in the world. And it's designed for 1,000 Starships a year. Producing 1,000 Starships annually translates to 2 or even 3 completed vehicles every single day. For anyone familiar with aerospace manufacturing, the idea sounds nearly impossible. Rockets have historically been defined by complexity, delicate engineering, slow timelines, and soaring costs. Yet Giga Bay aims to overturn that narrative completely. The scale of this new facility is what makes this output achievable. Giga Bay is expected to span around 700,000 square feet, totaling more than 65,000 square meters. The structure will also rise to roughly 380 feet or 116 meters, tall enough to support full assembly of Super Heavy boosters and Starships under a single roof. This massive internal volume will allow teams to work on 10 to 15 prototypes at the same time. Combined with advanced manufacturing systems for stacking, welding, stage separation, and automated assembly, Giga Bay will operate at a speed and scale no other rocket factory has ever matched. And these ambitious goals refer strictly to the fabrication process. They do not include testing, installation, or refurbishment. Even without reaching full optimization, Giga Bay is expected to produce multiple Starships per day. This capacity isn't just an impressive milestone, it's a requirement for the future SpaceX is building. When Starship begins full-scale missions to Mars, launch opportunities will arrive in short windows. During those periods, SpaceX may need to support more than 10 launches a day. Even with full reusability, that profile demands a massive fleet ready to fly. Tanker Starships, for example, will be crucial for orbital refueling. Many tanker vehicles will not be reused, and a single deep space mission may require more than 10 rapid-fire refilling flights. To meet this demand, enormous inventory is essential, and only a facility like Giga Bay can supply it. Giga Bay in Texas is just the starting point. SpaceX is already planning an equivalent facility in Florida, with similar scale and capability. Once both locations reach full production, the combined system could manufacture as many as 2,000 Starships per year. That means 4 to 6 Starships every single day. These numbers are unprecedented in the aerospace industry. For comparison, traditional rockets are typically produced in timelines measured in months or even years. NASA's Space Launch System, for example, required nearly a decade of development and tens of billions of dollars to complete just one vehicle. Giga Bay moves in the opposite direction. As output scales upward, the cost per Starship will continue to fall. The use of stainless steel, streamlined manufacturing techniques, and a mass production model dramatically reduce costs. Even the construction cost of Giga Bay itself marks a major shift. The facility is expected to cost around $250 million, the equivalent of only 4 Falcon 9 launches. This is a fraction of what most government-funded aerospace buildings require. Investing that amount to establish a manufacturing powerhouse reflects the bold, forward-thinking strategy behind SpaceX's vision. However, there's one improvement that could increase Giga Bay's long-term value. The structure should be built in a way that allows expansion or upgrades without requiring demolition. The current approach of tearing down large facilities to rebuild them is both time-consuming and resource-intensive. A modular upgrade-ready design would allow SpaceX to scale far more efficiently as Starship continues to evolve. Many observers believe this flexibility will be just as important as achieving high-volume output. As for current progress, SpaceX has already completed installation of 4 steel frame piles topped with cranes, forming the earliest outline of the building. From these foundation points, the general layout and orientation of Giga Bay are becoming visible. Over the coming months, major frame sections will begin to rise, followed by roofing, wall panels, interior walkways, and eventually the office and monitoring spaces positioned at the upper levels of the structure. Once complete, the facility will be filled with assembly stands, overhead cranes, robotic welding stations, and stage integration systems. The original timeline gave SpaceX the entire next year to complete construction, but judging from past projects, that schedule may speed up. Mega Bay 2, for instance, was built in less than 3 months. Given Giga Bay's larger scale along with the additional system installations required, the final timeline may still land under 1 year. If everything stays on pace, Giga Bay could become operational as early as the 3rd quarter of next year. When that moment arrives, the world will see the most aggressive high-volume rocket production system ever built. Its capacity will redefine aerospace manufacturing and push the industry into an era where rockets are produced with the speed and efficiency of automobiles. We are on the edge of something unprecedented. Are you ready to witness the beginning of the most intense rocket production era in history? If so, let me know with a Giga, typed in all caps in the comments below. SpaceX understands that building Giga Bay is only one part of creating a complete, high-volume production ecosystem. For Giga Bay to reach its full potential, every other manufacturing system at Starbase must scale to match its output. That effort begins with Star Factory, the backbone of Starship part fabrication. The exterior of Star Factory is now essentially finished, and remaining upgrades focus on internal support systems that directly affect production flow. Even with the limited glimpses offered through the rare photos taken inside, it's clear the facility has already accelerated its output. Recent images show rows of completed nose cones and cylindrical rings, indicating a surge in fabrication speed. Yet this improved pace is only a fraction of what Star Factory must eventually achieve. If Giga Bay is expected to produce 1,000 Starships per year, then Star Factory must deliver an equally massive volume of components. Every ring, dome, thrust structure, flap, and nose cone must arrive on schedule to keep stacking operations moving without interruption. Otherwise, the immense potential of the stacking bays will remain underutilized. This challenge is enormous, but it is well within SpaceX's capabilities. The company is pushing toward a manufacturing style common in automotive production, but virtually unheard of in aerospace. A true mass production line supported by automation, specialization, and continuous workflow. Musk has explained that Star Factory will rely on a linear chain of highly specialized workstations. Each station focuses on a single task: welding a stainless steel segment, installing plumbing, attaching insulation, or completing quality checks. The advantage of this system is efficiency. Production never pauses. There's no idle time spent waiting for another team or step in the process to catch up. Large engineering projects often suffer from downtime when one section cannot proceed because another is behind schedule. With Star Factory's layout, each unit moves from station to station with consistent rhythm. This approach also makes it easier to identify and correct errors before they spread downstream. Despite the ambition behind the design, much of Star Factory's internal workflow remains hidden from the public. Observers must rely on occasional interior photos or images captured during rare tours. Still, the steady rise in visible output strongly suggests that the workflow is scaling up. This timing is critical because SpaceX is now entering the V3 era of Starship. Unlike earlier versions, V3 is engineered for sustained, high-value missions. It will launch, perform in orbit, land reliably, and carry out key roles in refilling operations. Refilling alone requires a massive fleet of tanker Starships ready to launch back-to-back. To support that fleet, SpaceX must reach maximum production capacity, sooner rather than later. Beyond Star Factory, both Mega Bay 1 and Mega Bay 2 must also increase their production cadence. Although Giga Bay is scheduled to become operational in the second half of 2026, the first half of the year is already filled with critical missions and rapid development milestones. Inside Star Factory, completed rings and nose cones are stacked across the floor, signaling that component production is currently outpacing stacking capacity. Meanwhile, activity inside the Mega Bays has not kept pace, with recent work focusing primarily on Booster 18 and Ship 39. To stay on schedule, the stacking tempo in both bays must accelerate through the end of this year and into the beginning of next year. Even once Giga Bay becomes operational, Mega Bay 1 and Mega Bay 2 will remain essential, and their output must continue at a consistent and efficient pace. Expansion isn't limited to Texas either. SpaceX also plans to construct a second Giga Bay in Florida, though no formal announcement has been made regarding a corresponding Star Factory in that region. To avoid a future bottleneck in which components must be transported long distances between states, SpaceX needs to accelerate plans for Star Factory 2 in Florida. Ideally, construction on both Giga Bay, Florida and Star Factory 2 should ramp up next year, so that by around 2027, the Florida site can achieve full production independence. This would give SpaceX two geographically separated, fully self-sufficient manufacturing ecosystems capable of producing hundreds of Starships at a time. All of these efforts point to a clear shift in SpaceX's priorities. The company is transitioning from experimental Starship development into true industrial-scale production. Starbase is rapidly becoming the world's first dedicated rocket manufacturing city, a place where dozens of prototypes are built, tested, and launched at a pace that would have seemed impossible just a few years ago. Giga Bay stands at the center of this transformation. Its scale, its technology, and its production targets exceed anything the aerospace industry has ever attempted. When combined with a fully developed Star Factory system, upgraded Mega Bays, and parallel manufacturing infrastructure in Florida, SpaceX will be capable of building rockets with unprecedented speed and efficiency. The look, energy, and atmosphere of Starbase will soon be entirely different from what we see today. It will become louder, faster, more crowded with hardware, and more ambitious with every passing month. The shift from hand-built prototypes to mass-produced interplanetary vehicles is already underway. Are you ready for the next evolution of Starbase? In any case, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay updated on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember to return for more space news.